is Jerome Escasas and I'm from Group 2 in Math, and now I'm going to show you how to solve and find the linear equation.
But let's start with the basics. Let's say if we have the equation x plus 4 is equal to 7. How can we solve for x? So keep in mind, x is simply a number. It's a number that you currently don't know the value of. What number plus 4 is 7? We know that 3 plus 4 is 7. Therefore, x is equal to 3. But now, what process must we use to solve for x?
X minus 3
Whenever
is
you want to
equals to
solve
9.
for x, you need to get x on one side of the equation by itself. So you need to move the 4 from the left side to the right side. Notice that the x and the 4 are separated by addition. The opposite of addition is subtraction. So you need to subtract both sides by 4. 7 minus 4 is equal to 3. Therefore, x is 3. Let's try this one. X minus 3 is equal to 9. So what should we do to solve for x? We need to do the opposite of what we see. Since we see a negative 3 on the left side, let's add 3 to both sides. Negative 3 plus 3 is 0, so those two numbers will cancel. And 9 plus 3, to add them, if you put 9 on the number line, whenever you need to add, travel 3 units to the right. 1, 2, 3. So 9 plus 3 is 12. Therefore, x is equal to 12.
And now I'm going to show you how to find and solve the x and y intercept.
Find the x and y intercepts for the equation below. Write your answers as coordinates. Now, a lot of times when you see an equation in this form, so this is in standard form, you're going to see teachers go ahead and make what they call an XY chart. So you're going to make an XY chart like that, and what you're going to do is put in 0 for the x to start with, and then we're also going to do another equation where we put in a 0 for the y. Now, when you put in 0 for the x, all right, that's going to be 2 times 0 plus 3y equals 6. And some teachers will actually even call this the cover-up method, because what you're going to do is you're going to take that first term, that 2x, and you're going to cover that up because 2 times 0 is just 0, so that's just going to be gone. So you're just going to have 3y equals 6. Solving that for y, of course, you get y equals 2. Now it says write your answers as coordinates, so 0 and the answer we got for y is 2, so that of course will give us the coordinates 0, 2, and that is going to be our y-intercept. Now we do the same thing for the x-intercept, except this time we are going to let the y be 0. So we're going to have 2x plus 3 times 0 equals 6. And of course 3 times 0 is 0. That term is gone. So you're going to have just 2x equals 6. So then you get, not y, silly, you're going to get x equals 3. Now when you write that as a coordinate, don't forget the 3 is going to come first because that's the x value, and then 0 is going to come second. So 3, 0 is going to be the x-intercept. So that's how you find the x and y-intercept for an equation that's in standard form.
And now I'm going to show you how to solve and find the slope.
Useful depending on what you are looking for, but we're going to focus on this one. And this one right over here, it's often called slope-intercept form. Slope-intercept form. And hopefully in a few minutes it will be obvious why it is called slope-intercept form. And before I explain that to you, let's just try to graph this thing. I'm going to try to graph it. I'm just going to plot some points here. So x, comma y, and I'm going to pick some x values where it's easy to calculate the y values. So maybe the easiest is if x is equal to 0. If x is equal to 0, then 2 times 0 is 0. That term goes away, and you're only left with this term right over here. Y is equal to 3. Y is equal to 3. And so if we were to plot this, actually let me start plotting it. So that is my y-axis. And let me do the x-axis. So that can be my x. Oh, that's not as straight as I would like it. So that looks pretty good. All right, that is my x-axis, and let me mark off some hash marks here. So this is x equals 1, x equals 2, x equals 3. This is y equals, let me do this, y equals 1, y equals 2, y equals 3, and obviously I can keep going, This would be y is equal to -1. This would be x is equal to -1, -2, -3, so on and so forth. So this point right over here, 0, 3, this is x is 0, y is 3. Well, the point that represents when x is equal to 0 and y equals 3, we're right on the y-axis. If they have a line going through it and this line contains this point, this is going to be the y-intercept. So one way to think about it, the reason why this is called slope-intercept form, is it's very easy to calculate the y-intercept. The y-intercept here is going to happen when it's written in this form. It's going to happen when x is equal to 0 and y is equal to 3. It's going to be this point right over here. So it's very easy to figure out the intercept, the y-intercept, from this form. Now you might be saying, oh, well, it's a slope-intercept form. It must also be easy to figure out the slope from this form. And if you made that conclusion, you would be correct. And we're about to see that in a few seconds. So let's plot some more points here. And I'm just going to keep increasing x by 1. So if you increase x by 1, so we could write that our delta x, our change in x, delta Greek letter, this triangle's Greek letter delta represents change in x here is 1. We've just increased x by 1. What's going to be our corresponding change in y? What's going to be our change in y? So let's see, when x is equal to 1, you have 2 times 1 plus 3 is going to be 5. So our change in y is going to be 2. Let's do that again. Let's increase our x by 1. Change in x is equal to 1. So then if we're going to increase by 1, we're going to go from x equals 1 to x equals 2. Well, what's our corresponding change in y? Well, when x is equal to 2, 2 times 2 is 4 plus 3 is 7. Well, our change in y is equal to 2. We went from 5. When x went from 1 to 2, y went from 5 to 7. So for every 1 that we increase x, y is increasing by 2. So for this linear equation, our change in y over change in x is always going to be, our change in y is 2 when our change in x is 1, or it's equal to 2. Or we could say that our slope is equal to 2. And let's just graph this to make sure that we understand this. So when x equals 1, y is equal to 5. And actually, we're going to have to graph 5 up here. So when x is equal to 1, y is equal to, and actually this is a little bit higher. Let me clean this up a little bit. So this one, let me erase that a little bit, just like that. So that's y is equal to 4, and this is y is equal to 5. So when x is 1, y is equal to 5. So it's that point right over there. So our line is going to look, you only need 2 points to define a line. Our line is going to look like, let me do this in this color right over here. Our line is going to look like, let me see if I can, I didn't draw it completely at scale, but it's going to look something like this. This is the line. Y is equal to 2x plus 3. And we already figured out that its slope is equal to 2. When our change in x is 1, our change in y is 2. If our change in x was negative 1, our change in y is negative 2. And you could see that if from 0 we went down 1, if we went to negative 1, then what's our y going to be? 2 times negative 1 is negative 2 plus 3 is 1. So we see that the point 1, or the point negative 1 comma 1 is on the line as well. So the slope here, our change in y or change in x, if we're going from between any 2 points on this line, is always going to be 2. But where did you see 2 in this original equation? Well, you see the 2 right over here. And when you write something in slope-intercept form, where you explicitly solve for y is equal to some constant times x to the first power plus some other constant, This second one is going to be your intercept, your y-intercept, or it's going to be a way to figure out the y-intercept. The intercept itself is this point, the point at which the line intersects the y-axis. And then this 2 is going to represent your slope. And that makes sense because every time you increase x by 1, you're going to multiply that by 2, so you're going to increase y by 2. So this is just a kind of a get your feet wet with the idea of slope-intercept form, but you'll see, at least for me, this is the easiest form for me to think about what the graph of something looks like. Because if you were given another linear equation, let's say y is equal to negative x plus 2. Well, immediately you say, okay, look, my y-intercept is going to be the point 0, 2. So I'm going to intersect the y-axis right at that point. And then I have a slope of, the coefficient here is really just -1. So I have a slope of -1. So as we increase x by 1, we're going to decrease y by 1. Increase x by 1, you're going to decrease y by 1. If you increase x by 2, you're going to decrease y by 2. And so our line is going to look something like this. Let me see if I can draw it relatively neatly. It's going to look something. I can do it a little bit better than that. It's because my graph paper is hand drawn. It's not ideal, but I think you get the point. It's going to look something like that. So from slope-intercept form, very easy to figure out what the y-intercept is, and very easy to figure out the slope. The slope here is -1. That's this -1 right over here, and the y-intercept is the point 0, 2. Very easy to figure out because essentially that gave you the information right there.
Now I'm gonna show you how to find and solve the slope with a point and an ordered pair.
Find the slope of the line that goes through the ordered pairs 4, 2 and -3, 16. So just as a reminder, slope is defined as rise over run, or you could view that rise is just change in y, and run is just change in x. The triangles here, that's the delta symbol. It literally means change in. Or another way, and you might see this formula, and it tends to be really complicated, but just remember it's just these two things over here. Sometimes slope will be specified with the variable m, and they'll say that m is the same thing, and this is really the same thing as change in y. They'll write y2 minus y1 over x2 minus x1. And this notation tends to be kind of complicated, but all this means is you take the y value of your endpoint and subtract from it the y value of your starting point. That'll essentially give you your change in y. And it says take the x value of your endpoint and subtract from that the x value of your starting point, and that'll give you change in x. So whatever of these work for you, let's actually figure out the slope of the line that goes through these 2 points. So we're starting at, and actually we could do it both ways. We could start at this point and go to that point and calculate the slope, or we could start at this point and go to that point and calculate the slope. So let's do it both ways. So let's say that our starting point is the point 4, 2, and let's say that our endpoint is -3, 16. So what is the change in x over here? What is the change in x in this scenario? So we're going from 4 to -3. If something goes from 4 to -3, what was its change? Well, you have to go down 4 to get to 0, and then you have to go down another 3 to get to -3. So our change in x here is -7. Actually, let me write it this way. Our change in x is equal to -3 minus 4, which is equal to -7. If I'm going from 4 to -3, I went down by 7. Our change in x is -7. Let's do the same thing for the change in y. And notice, I implicitly use this formula over here. Our change in x was this value, our endpoint, our end of x value, minus our starting x value. Let's do the same thing for our change in y. Our change in y, if we're starting at 2 and we go to 16, that means we moved up 14. Or another way you could say it, you could take your ending y value and subtract from that your starting y value, and you get 14. So what is the slope over here? Well, the slope is just change in y over change in x. So the slope over here is change in y over change in x, which is, our change in y is 14, and our change in x is -7. And then if we want to simplify this, 14 divided by -7 is negative 2. Now what I want to show you is that we could have done it the other way around. We could have made this the starting point and this the end point. And what we would have gotten is the negative values of each of these, but then they would have canceled out, and we would still get -2. Let's try it out. So let's say that our start point was -3, 16. And let's say that our end point is the 4, 2. 4, 2. So in this situation, what is our change in x? Our change in x, if I start at -3 and I go to 4, that means I went up 7. Or if you want to just calculate that, you would do 4 minus -3. 4 minus -3. But needless to say, we just went up 7. And what is our change in y? Our change in y over here, or we could say our rise. If we start at 16 and we end at 2, that means we went down 14. Or you could just say 2 minus 16 is -14. We went down by 14. This was our run. So if you say rise over run, which is the same thing as change in y over change in x, our rise is -14, and our run here is 7. So notice, these are just the negatives of these values from when we swap them. So once again, this is equal to -2. And let's just visualize this. Let me just do a quick graph here just to show you what a downward slope would look like. So let me draw our 2 points. So this is my x-axis. That is my y-axis. So this point over here, 4, 2. So let me graph it. So we're going to go all the way up to 16. So let me save some space here. So we have 1, 2, 3, 4. It's 4, 1, 2. So 4, 2 is right over here. 4, 2. Then we have the point -3, 16. So let me draw that over here. So we have -1, 2, 3, and we have to go up 16. So this is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So it goes right over here. So this is -3, 16. -3, 16. So the line that goes between them is going to look something like this. Try my best to draw a relatively straight line. That line will keep going. So the line will keep going. So that's my best attempt. And now notice, it's downward sloping. As you increase in x value, the line goes down. It's going from the top left to the bottom right. As x gets bigger, y gets smaller. That's what a downward sloping line looks like. And just to visualize our change in x's and our change in y's that we dealt with here, when we started at 4 and we ended at, or when we started at 4, 2 and ended at -3, 16, that was analogous to starting here and ending over there. And we said our change in x was -7. We had to move back. Our run, we had to move in the left direction by 7. That's why it was -7. And then we had to move in the y direction. We had to move in the y direction +14. So that's why our rise was positive. So it was 14 over -7 or -2. When we did the other way, we started at this point. We started at this point and then ended at this point. Started at -3, 16 and ended at that point. So in that situation, our run was +7. And now we had to go down in the y direction since we switched the starting and the end point. And now we had to go down -14. Our run is now +7, and our rise is now -14. Either way, we got the same slope.
And lastly, I'm going to show you how to find and solve the system of linear equation.
So let's say you had two equations. One is x plus 2y is equal to 9. And the other equation is 3x plus 5y is equal to 20. Now, if we did what we did in the last video, we could graph each of these. These are lines. You could put them in either a slope-intercept form or
point slope form. They're in standard form right now. And then you could graph each of these lines, figure out where they intersect, and that would be a solution to that. But it's sometimes hard to find, to just by looking, figure out exactly where they intersect. So let's figure out a way to algebraically do this. And what I'm going to do is the substitution method. I'm going to use one of the equations to solve for one of the variables, and then I'm going to substitute back in for that variable over here. So let me show you what I'm talking about. So let me solve for x using this top equation. So the top equation says x plus 2y is equal to 9. I want to solve for x, so let's subtract 2y from both sides of this equation. So I'm left with x is equal to 9 minus 2y. This is what this first equation is telling me. I just rearranged it a little bit. The first equation is saying that. So in order to satisfy both of these equations, x has to satisfy this constraint right here. So I can substitute this back in for x. We're saying this top equation says x has to be equal to this. Well, if x has to be equal to that, let's substitute this in for x. So the second equation will become 3 times x. And instead of an x, I'll write this thing. 9 minus 2y. 3 times 9 minus 2y plus 5y is equal to 20. That's why it's called a substitution method. I just substituted for x. And the reason why that's useful is now I have one equation with one unknown, and I can solve for y. So let's do that. 3 times 9 is 27. 3 times negative 2 is negative 6y plus 5y is equal to 20. Add the negative 6y plus the 5y. Add those two terms. You have 27. See, this will be minus y is equal to 20. Let's subtract 27 from both sides. And you get, let me write it out here. So let's subtract 27 from both sides. The left-hand side, the 27s cancel each other out, and you're left with negative y is equal to 20 minus 27 is negative 7. And then we can multiply both sides of this equation by negative 1. Multiply both sides by negative 1. We get y is equal to 7. So we found the y value of the point of intersection of these two lines. Y is equal to 7. Let me write it over here. Y is equal to 7, so I don't have to keep scrolling down and back up. Y is equal to 7.